let's calculate the solubility of lead 2 sulfate in water. I know I just threw the words in water into the problem. That actually doesn't change what we've been doing.
You just add H2O.
No, it's just in water. The ones we were working earlier, those were in water as well. Okay? But we're going to work this one, and then I'm going to put it in something besides water. PbSO4. Using the X's and the KSP's, what's it going to be? It's going to be that KSP is equal to X squared. So I'll look up the KSP. For X, I'm sorry. Y'all pretend it said calculate the molar solubility, because I didn't want to do the whole molar mass thing. Do y'all get 1.3 times 10 to the minus 4? For X? What would happen if I said calculate the molar solubility of, we're still going to do the lead 2 sulfate, the PbSO4, but instead of trying to get it to dissolve in pure water, let's put it in lead 2 sulfide. Let's put it in 0.10 molar lead 2 sulfide. Okay, since it's lead 2 sulfide, guys, do you see that that formula is PbS? Do you see then that it would be 0.1 molar lead and 0.1 molar sulfide? Provided all of it dissolved, okay? Now, if we look back up here to this KSP equal to X squared, how we got that is we said the concentration of the lead ions, which would be X, times the concentration of the sulfate ions, which would be X, and we put those together and said KSP is equal to X squared, right? But when we set up that ice table, and how we started doing it at the beginning of class, is we said initially there's no lead and no sulfate, so the change is going to be X and X, right? Because we were putting them in pure water. But now I'm not putting it in water, I'm putting it in something, lead 2 sulfide, that has a common ion. We've talked about common ion before when we introduced buffers. What is the common ion between lead 2 sulfide and lead 2 sulfate? It's lead. So this Pb plus 2 is no longer starting at 0. Now it's starting at 0.1 molar because it's not in water. So how that changes the KSP, it's still going to be that the KSP is lead plus 2 times sulfate, but now these both aren't starting out at X. Now the lead 2 is starting at 0.1, and the sulfate is still X, and that's still going to be equal to the same KSP, which is 1.8 times 10 to the minus 8. Now we just simply divide that by 0.1.
Why are we not doing the PBS?
Because that's already in the solution. I'm wanting to know what the molar solubility of the PbSO4 is. This is in a different color. That's in red. I took that. What do y'all get for X?
So the KSP we're using, or would you use that for the?
For the lead 2 sulfate. Blah, 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 blah. It is the molar solubility of the lead 2 sulfate. It's just moving the decimal, but I can't. Thank you. X is 1.8 times 10 to the minus 7 molar. Is that what y'all got? Okay, if I think through it, guys, the one up top here, when I put it in pure water, my solubility is 1.3 times 10 to the minus 4. But when I try to get it to dissolve in a solution that has a common ion, the lead 2 sulfide, my solubility is 1.8 times 10 to the minus 7. Which of those is a bigger number? The 1.3 times 10 to the minus 4 is a bigger number. What does that tell me? That more will dissolve in pure water than will dissolve in a solution where there is a common ion. And that makes sense, doesn't it? That more would dissolve in water than in a solution that's already got something dissolved in it.